Scientific notation is a way in which we can represent a number. It is shorter to represent very small or large numbers, so you don't have to write all those zeros. More importantly, it is used to round to appropriate number of significant figures, especially when it comes to insignificant zeros. So when we're looking at the general form of scientific notation, we have this m times 10 to the n. What these variables mean, that capital M is what is called a mantissa. The mantissa represents a significant digit, a significant figure between 1 and 9. Only the ones place can be occupied. So you will place the decimal after the ones place and then however more significant figures you have remaining past there. N is that power of 10 from that metric unit. It is going to be your exponent. It represents how many times you need to move your decimal to allow for the mantissa to have the appropriate place values. What this looks like. Let's say we have a number. So we've got our hundreds, thousands, millions, so 3,500,000,000 as our number. These zeros are insignificant because there's no decimal, but they are just allowing the 3 to be in the billions place and the 5 to be in the 100 millionths place. Therefore, these are our two significant figures. Writing those zeros, pretty redundant, also not necessary, especially when we have scientific notation. So this 3 and 5, these are your mantissa. They become the 3.5 because we always want the ones place occupied and then any other significant digit trails past that 1. What we need to determine next is how many times are we going to move that decimal place. From that decimal all the way to the end of that number are our place values that we need to account for. Each place value is a change of 10. So when we look at this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 place values. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 essentially of those place values in which we want to represent. That again is tedious. So what we can do is turn this into the power of 10. So we have a 10 and then we count how many zeros there are. There are 9 zeros, so 10 to the 9th. Therefore, our number is 3.5 times 10 to the 9th. 3.5 is that mantissa. It shows us our number of significant figures. Our 9 is the n or the exponent. It tells us how many zeros or how many place values we need to move. The other way you could look at this is how many times I'm going to move that decimal. So if I have my decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9. It is the same thing. So what I've done there is to break it down to you how the mantissa is represented, where the place values for 10 to the 9 came from that you also saw during the metric units. What if we have a small number? We still need to identify that mantissa. The mantissa is going to be the significant digits within that number. Actually, I'm going to add another 0 in here. We need to remember our sig fig rules. We have to start with the first real digit, a new significant number. So that's going to be our 3, and we need to make sure we end with a significant digit. That's going to be 5. The 0 in between the two is the sandwiched 0. So we have 3 significant figures. That is our mantissa. So it's going to be 3.05 is what's going to occupy that place. How many times are we moving that decimal to put the 3 in the ones place? 1, 2, 3, 4, 5. So that means it is 10 to the negative 5. Note that when you have a positive exponent, you have a large number, a number above 1. When you have a negative exponent, you have a number that is less than 1 or much smaller. So that exponent tells us big number, small number. The mantissa tells us how many sig figs. And it shortens it up to exactly what we need to know. Significant figures, place values. You can work scientific notation in your calculator. So I'm first going to be working with the TI-30X2. With this calculator, you want to know the different functions. With working with the exponent, the buttons you need to know is the second, and then above this x, you see that EE. That EE is the exponent. It is what turns a value into scientific notation. All right, so if I have a number 2.5, I'm going to click second E. That E represents 10, and then we will put the exponent number on there. So I'm going to put a 9. All right, so when I have that value, it can put all those digits in there because my calculator has room. The other thing I can do is I can convert this calculated number into scientific notation. So I'm going to hit the second, where we see that psi, I'm going to hit there, over to scientific, and there's my number in scientific notation. All right, so it is a lot easier to type scientific notation or exponents when you use the E function. For a Casio, I do not have one of the newer Casios, but it has roughly the same numbers. So Casios are a little bit different. So I'm going to put my 2.5 in there. They have an EXP button. So you're going to hit the EXP, and then you have that E. So I'm going to put the 9, and you have that value as well. So to go into scientific notation, it's going to be a little bit different for newer Casios, but it's essentially the same. So if you see, Casios are going to have a mode button. We're going to click mode, and I just keep going across until I find what I am looking for. And here's that psi. So scientific notation 2, and then yes, we want that value. So I'm going to do 2.5 E9 mode 2, and I'm able to get that scientific notation. So it's not as easy as it is with the TI, but it is doable.